So I want you to just take a second and look around wherever you are right now. The lights overhead, the screen you're reading this on, the hum of the AC keeping the room cool. Like, absolutely none of it works without the invisible backbone of the electrical grid.
Right. People just assume the power is always going to be there.
Exactly. And we aren't talking about the glamorous parts of the energy transition here. We're not doing a deep dive on, like, sprawling solar farms or offshore wind turbines today.
No, we are getting into the real hardware.
Yeah, the hardware that actually bridges the gap between raw high-voltage generation and the standard outlet in your wall. I'm talking about transformers. They're basically the ultimate physical middlemen of the modern world.
They really are.
And so our mission for this deep dive is to unpack a stack of research on one specific company that's sitting right at the high-stakes center of this whole global electrification boom.
Shilchar Technologies, Ltd.
Right. SHILCTECH on the ticker. We're going to try to figure out if this Indian manufacturer is just, catching a temporary cyclical wave of infrastructure spending, or
if they've genuinely built a durable moat in what is essentially a notoriously difficult corner of the heavy industrial sector.
Exactly. And it's a company that forces you to really look at the physical reality of the grid,
Or absolutely.
Yeah.
I mean, we're dissecting an entity operating out of Vadodara, Gujarat, that makes the literal nuts and bolts of energy transmission. But this isn't just an audit of a single balance sheet, right?
No, definitely not.
It's a lens into how the physical architecture of the global energy transition is fundamentally changing. Yeah. Because we often get entirely consumed by the software side of things.
Yeah, the smart meters, the grid management software.
Right, or the high-level policy mandates. But underneath all of that abstract policy, someone actually has to bend the steel. They have to wind the copper, process the insulating oil, and literally build the multi-ton boxes that make the physics of electricity transmission possible.
I mean, I was looking at their product range to start, and this is what tripped me up immediately. The sheer physical variance of what they manufacture is it's wild.
It spans a huge spectrum.
Yeah. They make power transformers, distribution transformers, and then like specialty electronics and telecom ones too. But the scale, the research mentions they build distribution units starting at 5 kVA, going up to 3,000 kVA. And then their power transformers run from 3 MVA all the way up to the 50 MVA, 132 kVA class for subtransmission. I was honestly struggling to visualize the actual difference between a 5 kVA unit and a 50 MVA unit.
Well, the physical disparity is staggering. I mean, it dictates entirely different manufacturing processes.
Yeah.
When we talk about kVA, kilovolt amperes and MVA, megavolt amperes, we're measuring the apparent power the unit can handle.
Okay.
So a 5 kVA distribution transformer, that's relatively tiny. It's the sort of pole-mounted metal canister you might see in a rural area.
Like the gray trash can-looking things on telephone poles?
Exactly. It's designed to step down power for just a few houses, maybe a small agricultural pump. It weighs maybe a few hundred kilograms.
Okay, so a few guys in a small truck can handle it.
Right. But on the other end of the spectrum, that 50 MVA power transformer operating at 132 kV, which means it handles 132,000 volts, by the way.
Wow.
That is a serious piece of heavy infrastructure. We are talking about a unit the size of a small house.
A house? Really?
Yeah, weighing tens of tons. And it's filled with thousands of liters of highly refined mineral oil just for cooling. It requires specialized multi-axle trailers just to move it down the highway.
That's incredible.
And its job is to step down the raw power coming from the regional transmission grid so it can actually be fed into a city's primary substation or maybe a sprawling industrial complex.
And reading through the operational notes, they aren't stamping these 50-ton behemoths out on an assembly line, right? Like they aren't just tossing them in a warehouse hoping utility eventually buys one.
No, not at all.
Their business model is strictly order-driven, which implies, a pretty high level of custom engineering for every single unit rolling out of that factory in Gujarat.
It is entirely bespoke engineering. And you have to understand, that is a crucial distinction from an inventory-driven manufacturing business.
Right.
Shilchar isn't making standard off-the-shelf boxes. They're engineering customized solutions for specific grid nodes or, specialized renewable energy plants or highly specific industrial environments.
Because no two grid locations are exactly the same.
Exactly. When an order comes in from a buyer, it comes with this dense manual of technical specifications. It has to meet exact voltage step-down requirements, highly specific thermal constraints based on the local climate.
Because India's climate varies so much.
Right, and it has to match the unique load profiles of that specific location on the grid. Like, if it's going to a solar park, the transformer has to handle daily cyclical loading.
What does that mean in practice?
Well, it runs incredibly hot during the peak afternoon sun when generation is maxed out, and then the load drops to near zero at night.
Oh, right. No sun, no power.
Exactly. And that constant thermal cycling stresses the internal components completely differently than, say, a transformer running a continuous steady base load for a cement factory.
Right, so it's not a generic piece of hardware at all. The analogy that kept coming to mind while I was reading this, well, the notes mention bespoke tailoring, like comparing off-the-rack suits to a bespoke suit.
That's a good way to look at it.
Yeah, like Shilchar isn't churning out standard lowest bidder street corner transformers. They are doing the bespoke tailoring for complex renewable plants. But the other analogy that kind of hit me was almost like organ matching for a transplant.
Oh, I like that.
Because the grid is this living, breathing, biological system, right, with its own frequencies and voltage quirks. So utilities don't just want a cheap transformer. They need a biological match that won't trigger the grid's immune system.
You want to avoid power surges or localized blackouts.
Exactly. Harmonic distortions, all that stuff. That bespoke engineering is essentially tissue typing the manufacturer's product to the utility's exact substation.
That is a much more accurate way to view it than just seeing it as a simple commodity purchase. And because it requires that level of, biological matching to the grid, you have to look really closely at the dynamics of who is actually doing the buying versus who the end user is.
Because they aren't always the same entity.
Usually they aren't. Their customer buckets are highly defined. You have your state discoms, the distribution companies and government utilities.
Right.
Then you have private utilities. You have EPC contractors, which are the engineering, procurement, and construction firms. They're the ones who actually bid on and build large infrastructure projects on behalf of the government or private players.
Okay, got it.
You also have renewable developers building solar, wind, and hydel plants. And finally, industrial captive users. So cement, steel, oil and gas refineries that require their own dedicated power infrastructure.
But the entity writing the check to Shilchar, say, an EPC contractor building a solar park, they're often different from the utility that will eventually operate and maintain that grid asset for the next 30 years, right?
Exactly. The EPC buys the suit, but the utility has to wear it for 3 decades.
That makes sense. I also noticed the export angle in their revenue breakdown, and honestly, it seems like a disproportionately large piece of the pie for a mid-sized Indian manufacturer.
The huge driver for them.
Yeah, over 30% of their specialized electronics transformers go overseas. And looking at recent years, exports made up roughly 43% to 48% of their total revenue.
Nearly half.
Which is wild. Exporting highly technical, heavy machinery out of India to demanding markets like the Middle East and North America, I have to imagine that fundamentally alters the operational DNA of the company. I mean, how does a facility in Vadodara convince a utility in the Middle East to trust them with a critical grid node?
Well, it forces a completely different level of operational rigor and testing. When you're exporting nearly half your revenue in this specific high-stakes sector, you are entirely removed from competing on just being the cheapest local option in a domestic tender.
You can't just win on price anymore.
Exactly. You are navigating international compliance standards, incredibly strict quality control audits, and just mountains of rigorous documentation.
Right.
Because think about it. If an EPC contractor in the Middle East is trusting an Indian manufacturer to ship a 142 kV power transformer across the Arabian Sea, that product absolutely cannot fail.
I can't even imagine the headache if it did.
The sheer logistical cost of a failure is catastrophic. You have the downtime on the grid, the nightmare of shipping a 50-ton defective unit back, procuring the specialized cranes required to swap it out.
Just a total disaster.
Yeah. So to even be considered for those export contracts, Shilchar has to maintain testing bays and engineering tolerances far beyond what a local manufacturer supplying lower-tier regional projects would ever need.
That makes sense. But I do have to push back on this strategy a bit, the strategy of spanning the entire board.
Okay, what do you mean?
Well, is there a structural risk in them trying to be everything to everyone? Like, they manufacture tiny 5 kVA distribution units for rural electrification, and they are simultaneously engineering 50 MVA subtransmission units for major substations, while also making telecom and electronics transformers. Doesn't trying to cover that vast of a spectrum dilute their engineering focus?
It's a fair question. The risk of product dilution is a valid concern, and it definitely creates tension on the factory floor regarding capital allocation and workforce training.
Because it's different skill sets, right?
Yes and no. The core competencies of transformer manufacturing are actually highly transferable across those size classes. The fundamental physics remain exactly the same.
Okay.
It always requires sourcing and slitting CRGO steel for the magnetic core, winding electrolytic copper for the coils, processing and testing the insulating oil, and running high-voltage testing protocols before dispatch.
So the ingredients are the same, just a different recipe.
Basically.
Mm-hmm.
And operating across those segments also provides a real revenue buffer.
Oh, I see. Like diversification.
Right. If domestic industrial capex slows down, perhaps the Middle East export market is accelerating.
Mm-hmm.
Or if large transmission projects get bogged down by, say, land acquisition issues, the rural distribution replacement cycle might provide steady cash flow.
That makes sense from a business stability standpoint.
But to your point, as they push aggressively into the really heavy 50 MBA and above categories, the engineering demands do shift dramatically.
Yeah, the stakes get higher.
The tolerances get tighter, the testing bays require higher voltage capacities, and the cost of a manufacturing defect becomes much, much more painful.
Right. So understanding what they build and the sheer complexity of shipping it globally, I think we need to address the structural demand driving all of this. Like, why is the order book so full right now?
The macro picture.
Exactly. Zooming out to the total addressable market, the TAM, the Indian transformer market, is supported by three distinct demand pools. You've got new network additions, you've got replacements and refurbishments, and then upgrades for loss reduction.
It's that second pool, the replacement cycle, that forms the baseline thesis you really have to grasp to understand the durability of this demand.
Because they don't last forever.
No, transformers do not run indefinitely. A typical distribution transformer has a theoretical depreciable lifespan of about 20 to 30 years.
Okay, 30 years sounds like a long time.
It does, but in reality, due to the operating conditions in India, they are frequently refurbished or entirely swapped out at the 15 to 20-year mark.
Really? That's a huge cut in lifespan.
It is, and if you look at the historical data of the installed base in India, an enormous amount of grid build-out and rural electrification happened in the early to mid-2000s.
Oh, right. So the math on that timeline is coming due right now.
Inescapably. Roughly 15 to 20% of the entire installed base of the Indian grid is currently sitting squarely in the replacement window.
See, I'm trying to picture the physical degradation here. If these units are essentially solid metal and copper filled with oil, what actually breaks down? Why do they fail at year 15 instead of year 30?
It comes down to thermal degradation.
Okay, because I was thinking about the temperatures we've been seeing globally, and specifically across urban India. We are looking at record peak temperatures and simultaneous spikes in air conditioning adoption.
That's the exact cocktail that kills them.
Aren't these transformers essentially just baking in the afternoon sun while being pushed to maximum load capacity?
Baking is the right word. The thermal degradation is exactly what ends their life early. See, that theoretical 30-year lifespan, that's calculated in a laboratory assuming ideal operating conditions.
Which don't exist in the real world.
Not at all. The lab assumes predictable, gentle thermal cycles, perfectly balanced phase loading, and clean power without any harmonic distortion. But reality is brutal. As we discussed, transformers are filled with highly refined mineral oil. That oil serves two purposes. It insulates the live components from the grounded tank, and it circulates to pull heat away from the copper windings.
Okay, so it's a coolant.
Yes, and the coils themselves are wrapped in specialized cellulose paper insulation. So when a sprawling urban center in India hits 45 degrees Celsius...
Which is what, like 113 Fahrenheit?
Yeah, incredibly hot. And when millions of air conditioners kick on simultaneously in that heat, the peak load stress is just immense. The copper windings heat up drastically.
And the oil can only do so much.
Right. When they run hot consistently over time, that cellulose paper insulation degrades at an accelerated rate. It becomes brittle. The oil itself degrades too, accumulating moisture and dissolved combustible gases.
That sounds dangerous.
It is. Because once that paper insulation breaks down and loses its dielectric strength, a short circuit occurs between the windings. And when that happens, the unit fails, often catastrophically, long before its 30-year anniversary.
Okay, so the grid is just being pushed past its absolute design limits, which forces a replacement cycle much faster than standard financial depreciation schedules would suggest.
Exactly.
It kind of reminds me of, well, think of a logistics company. It's like changing the tires on a fleet of trucks versus just buying new trucks, you know?
That's a great comparison.
The replacement market is the bread and butter that keeps the mechanics, or in this case, the manufacturers, busy, even when the broader economy slows down or new grid expansions are paused.
Right, because you can't just leave a neighborhood without power because a transformer blew. You have to replace the tires.
Exactly. That explains the base load of demand perfectly.
Hmm.
But you also have government mandates forcing upgrades, right? Like the notes highlight the RDSS scheme, the revamped distribution sector scheme, and the green energy corridor. These aren't just suggestions. These are heavily funded mandates to modernize the grid.
The policy layer accelerates everything. The RDSS scheme specifically targets the financial and operational health of state discoms.
How does that affect transformer demand?
Well, historically, a significant portion of the smaller distribution transformer market was serviced by regional, unorganized, informal repair shops.
Oh, like a mom and pop repair shop for the grid.
Essentially, yes, if a rural transformer blew, a local guy might just rewind it with lower grade materials and patch it back together.
Just to get the lights back on.
Right. But AT&C losses, aggregate technical and commercial losses in India, have historically been incredibly high due to this kind of patchwork.
So power is just bleeding out of the system.
Exactly. And now, as utilities are mandated by the RDSS to drastically reduce these technical losses and improve grid reliability, they can no longer rely on unverified local vendors.
They need actual data and warranties.
They require rigorous testing, certified low-loss cores, and proven failure rates. So this policy accelerates the formalization of the sector. It pushes demand away from the unorganized shops and directly toward certified, organized players like Shilchar.
And then the green energy corridor adds another layer to that, right?
A huge layer. Every single new gigawatt of solar or wind capacity requires complex step-up transformers at the generation site to push that power onto the transmission grid. It's an infrastructure boom.
So with a demand pie that large driven by aging infrastructure, climate-induced thermal stress, and these strict government modernization mandates, surely every major electrical conglomerate on the planet is fighting for market share here.
You'd think so, yes.
Where does a company out of Vadodara actually fit into this competitive landscape? Because looking at the data, the market appears to be highly fragmented at the bottom end with those smaller distribution units, but then heavily concentrated at the very top with the huge power and generation units.
It is a very stratified market. At the absolute top tier, you have the global giants and the large Indian conglomerates.
Yeah.
We're talking about companies like ABB, Siemens, Hitachi Energy, CG Power, and BHEL.
The heavyweights.
Yeah. They completely dominate the ultra-high specification, massive-scale utility projects. Stuff like the 400 kV and 765 kV transmission networks.
Okay, so Shilchar isn't fighting them for those.
No, not at all. Then you have a tier of mid-sized peers. Companies like Voltamp, Transformers and Rectifiers India, commonly referred to as TNR Indotech, and Varap Bijli.
And that's where Shilchar sits.
Shilchar positions itself in a very specific pocket within this mid-tier. The analysis categorizes them as a niche challenger.
And their specific niche strategy is interesting because it involves actively avoiding the most brutal, hyper-competitive segment of the market, the price-sensitive PSU and utility tenders.
Exactly.
Like, they aren't trying to outbid 20 other manufacturers for standard government contracts where literally the only metric that matters is the absolute lowest price. They are pivoting toward medium to small, custom engineering jobs, preferred EPC relationships, and those high-margin exports we discussed earlier.
And avoiding the direct PSU tender round is a vital margin preservation strategy.
Because it's just a race to the bottom?
It is. In those large state utility tenders, the buyer power is exceptionally high. It frequently degenerates into a brutal price war, often with punishing contract terms regarding raw material cost escalations. By sidestepping those highly commoditized segments, Shilchar protects its profitability.
That makes total sense.
Their competitive edge, their actual moat, is built on three specific pillars. First, the technology and engineering capability to deliver those custom, non-standard solutions and pass the rigorous third-party testing protocols at facilities like the Central Power Research Institute, or CPRI.
Okay, so they can pass the hard tests. What's the second pillar?
The incredibly high switching costs. inherent in their customer base.
Let's pull on that thread regarding switching costs, because we talked earlier about the idea of getting a bespoke suit or organ matching for the grid. Getting onto an EPC contractor's or a utilities-approved vendor list requires a staggering amount of time.
Years sometimes.
Right. The notes say it involves multi-year qualification cycles, exhaustive factory audits, and prototype testing under simulated grid faults.
It is not a casual vendor relationship.
It's kind of like, well, it's like getting past the strictest bouncer at an exclusive club.
Ah,
Once you're finally in, you don't want to leave, and the club definitely doesn't want to risk letting unverified strangers inside to cause trouble. Once a manufacturer finally clears those hurdles and proves they can supply equipment that doesn't destabilize the grid, the utility doesn't want to risk changing vendors.
and that barrier to entry for new competitors in the high-spec segment is formidable precisely because of that qualification process. I mean, think about it from the EPC's perspective.
Okay.
If a major EPC contractor knows that Shilchar consistently delivers on time, meets the exact thermal and electrical specs, and crucially doesn't cause catastrophic grid failures during the commissioning phase.
Why would they ever switch?
Exactly. The incentive to switch vendors is virtually non-existent. Why would an EPC risk utilizing an unproven manufacturer just to shave a few lakhs off the equipment cost?
The math just doesn't work out.
Right. The risk of a project delay, or worse, an asset failure that triggers a localized blackout far outweighs any minor upfront cost savings on the hardware. That relationship stickiness, their preferred partner status with these EPCs, acts as their third competitive pillar.
The research cautions against overestimating their cost advantage, right? Like being located in Gujarat, having a highly focused manufacturing setup that certainly aids efficiency.
It helps, sure.
But the analysis makes it clear that their cost advantage is only partly proven. Their real defensible moat is those multi-year vendor approvals and that bespoke engineering capability we just talked about, not necessarily being the absolute lowest cost producer on an Excel spreadsheet.
Which introduces a critical strategic dilemma as they continue to scale.
Yeah.
Because we know they are expanding into larger power transformers, pushing toward the 220 kilowatt class.
Right, stepping up in weight class.
Exactly. And as they move out of their established niche and into those higher voltage classes, they are inevitably going to bump into the established mid-tier players like Voltamp and TNR, and eventually the lower end of the global giants.
See, that seems like the defining risk of their growth narrative to me.
How so?
Well, they have a moat in their current niche, but they are still a mid-sized player in the grand scheme of the power sector. If they aggressively push into higher voltage classes to chase larger infrastructure projects, aren't they walking straight into a brutal price war with better capitalized competitors?
It's a very real danger.
Like, how does a mid-sized facility in Gujarat avoid getting crushed by a global balance sheet like Hitachi or ABB when bidding on a massive 220 kV substation?
It's tough because the engineering requirements scale non-linearly as you move up the voltage classes.
Meaning it gets a lot harder, a lot faster.
Exponentially harder. The insulation demands, the short-circuit withstand capabilities, the sheer physical size of the testing bays required. All of it becomes exponentially more complex and expensive. ABB and Hitachi possess global R&D budgets that a mid-sized Indian firm simply cannot match.
So how do they compete?
Shilchar's primary defense against those conglomerates is operational agility.
Speed.
Exactly. Think about a massive global entity. They might require months of internal approvals, cross-border engineering sign-offs, and just general bureaucratic friction to engineer a custom adjustment for a mid-sized renewable energy park.
Right. They move like a tanker ship.
But a niche challenger like Shilchar, with a flatter management structure and highly concentrated engineering teams, can move so much faster. They can adapt the design parameters on the fly and deliver the final product with significantly shorter lead times.
So they win on turnaround time.
Yes. Their survival in the larger voltage classes depends entirely on maintaining that rapid adaptability, not attempting to outscale companies with century-old global footprints.
Let's trace how that agility actually translates into financial performance, because the numbers outline a fascinating trajectory of scale here.
Financials are very telling.
Yeah, looking at their revenue growth. In FY24, they posted 396.88 crore. Then in FY25, that figure jumped a remarkable 57% to 623.15 crore.
A huge leap.
And then in FY26, the top line ticked up slightly, just to 651.94 crore.
And while the revenue growth is interesting, the profitability metrics accompanying that growth are what truly stand out in this sector.
The margins.
Yes, their EBITDA margins hovered around 30% in FY25, and they maintained roughly 29% for the full year in FY26.
Okay, so 30% high for this industry.
In the context of heavy industrial manufacturing, where you are dealing with immense physical logistics, volatile raw materials, and high fixed plant overhead sustaining operating margins near 30%, is highly anomalous.
Wow, okay, so it's basically unheard of.
It's very rare. It speaks to the premium pricing they command in that export and custom EPC market we discussed, and their profit after tax, or PAPAPITY, followed a very similar curve.
Right. They generated a 147 crore in FY24, stepping up to 158 crore in FY25, and remaining flat at 158 crore in FY26.
The export mix is clearly the fuel for those margins. 43% of revenue in FY25, climbing to approximately 48% in FY26.
But to process that sheer volume of orders, they had to physically expand, right? Like they increased their manufacturing capacity to 7,500 MVA in August 2024. And in FY25, they hit a 77% utilization rate on that newly expanded capacity.
They filled it up fast.
Very fast. And they aren't stopping there. The current plan is a substantial expansion to 14,000 MBA, which directly aligns with their move into that 220 key black class we were just talking about.
Right. And if you look closely at these timelines, we're observing a company transitioning between distinct operational phases.
What do you mean by phases?
Well, they went through a phase of rapid explosive throughput expansion from FY24 to FY25. That's where you saw the 57% revenue jump.
Okay, right.
But the data from FY26 represents what I would characterize as a capacity absorption phase.
Taking a breath.
Exactly. That flat net profit of 158 crore in FY26 shouldn't necessarily be interpreted as a failure of execution. It really just reflects the physical constraints and logistical realities of filling a newly expanded factory floor.
Because in a manufacturing environment, the utilization rate dictates everything.
Precisely. At 77% utilization, they are effectively absorbing their fixed costs. So the depreciation on the new plant, the core engineering staff, the baseline electricity just to run the facility.
Right, the lights are on.
And at 77%, the margins look excellent. However, any reduction in throughput immediately degrades profitability because those fixed costs remain static regardless of how many transformers actually roll out the door.
And we actually saw a very clear demonstration of what happens when that throughput gets disrupted.
The Q4 shock.
Yeah. In the fourth quarter of FY26, there was a severe contraction. The EBITDA margin abruptly dropped 21%.
A significant hit.
Yeah, and the research attributes this to a dual shock, shipping disruptions in the Middle East, and the price of transformer oil essentially doubling from its February levels.
That Q4 margin compression perfectly illustrates their vulnerability to external macroeconomic and geopolitical shocks.
It's like driving a sports car perfectly, but hitting a sudden pothole. The car is fine, but it really rattles the passengers.
That's exactly it. The shipping disruptions in the Red Sea and the Middle East fundamentally broke their logistics chain.
Because they couldn't get the ships.
Right. If they cannot secure a vessel to dispatch a completed transformer, it just sits on the factory floor.
And if it sits on the floor, they can't get paid.
Exactly. The revenue cannot be recognized on the books, and the final payment milestones from the EPC cannot be collected.
Just a total bottleneck.
And simultaneously, the raw material inflation hit their cost of goods sold. Transformer oil is a highly refined derivative of crude oil.
Oh, of course.
So when crude spikes globally, or refining capacity tightens, the cost of that insulating oil surges. And if Shilchar has already signed fixed-price contracts with their EPC clients months prior,
They're stuck holding the bag.
they are forced to absorb that input cost inflation directly into their margins before they can eventually try to pass it on to future orders.
But the broader growth narrative seems to have stalled even before that Q4 pothole, right? Like, revenue only grew 5% in FY26 after that massive 57% jump the year prior, and profit stayed totally flat at 158 crore.
That's true.
So I have to question if the structural growth story is already running out of steam here. Or is this simply the physical limit of the factory? Like, are they literally idling the engine, unable to push any more steel and copper through the doors until that new 14,000 MVA capacity comes online?
It's almost certainly the latter. The flattening of revenue in FY26 is a manifestation of capacity constraints rather than a sudden collapse in underlying demand.
They just couldn't build them fast enough.
Right. Heavy transformer manufacturing is fiercely constrained by physical space and testing bottlenecks. Once a facility reaches the upper bounds of its safe operating utilization, which is typically around the 80% to 85% mark, you simply cannot accept more large-scale orders without risking severe delivery delays.
Or skipping steps.
Exactly. And you can't compromise quality control protocols or bottleneck your high-voltage testing days. The flat performance in FY26 is literally the physical limit of the 7,500 MVA plant expressing itself on the income statement.
Wow, okay.
So to compound growth further and capture more of that long-term replacement cycle we talked about, the physical footprint must expand. Moving to 14,000 MVA and integrating 220 kV testing capabilities, that is a structural shift that changes their operational scale permanently.
Okay, so that vulnerability we saw in Q4, the delayed shipments and the spiking oil prices, that brings us directly to the systemic risks threatening this company.
Yes, the risks are substantial.
Let's examine what actually goes into constructing these transformers. The core materials are copper, CRGO steel, which stands for cold-rolled, grain-oriented steel aluminum, and the transformer oil. Together, these four materials constitute roughly 80% to 85% of their total raw material costs. And crucially, the notes emphasize they have limited natural hedging against price swings.
This is the classic commodity trap for any heavy equipment manufacturer, and the physics of the materials make it particularly difficult to manage.
How so?
Well, let's look at CRGO steel. It is not standard construction steel. You can't just buy it anywhere. It is a highly specialized metallurgical product.
Okay.
It's processed to align the magnetic domains within the steel grains, allowing it to carry the magnetic flux generated by the alternating current with minimal energy loss.
Sounds expensive.
It is incredibly difficult to manufacture, and there are only a handful of steel mills globally capable of producing high-grade CRGO. India imports a vast majority of its requirement.
Oh, wow. So if there's a hiccup anywhere in the world...
Exactly. If global supply chains snarl, or if the few producing mills decide to raise prices, Shilchar has very few alternative sourcing options. They just have to pay it.
And copper is similarly volatile, right?
Very. Copper is traded on global spot markets and highly sensitive to macroeconomic trends. If Shilchar enters into a fixed-price contract with an EPC to deliver a batch of substations in 9 months, and the spot price of copper surges in month 4 due to global supply shortages.
Shilchar has to purchase that copper at the elevated price and eat the margin loss.
Precisely. They are continuously caught in a vice between fixed revenue contracts and variable cost inputs.
And consider the macro environment for copper right now. Like, if global copper prices continue to break record highs, driven by the huge build-out of AI data centers and the transition to electric vehicles, specialized transformer manufacturers might face a permanent structural margin squeeze.
It's a very real possibility.
If the utility buyers flatly refuse to accept higher equipment prices, the manufacturers are the ones who bleed.
Right.
But the raw materials are only half the risk profile here. Let's look at their customer base, because the research explicitly states that their top 5 clients contributed approximately 58% of their FY25 revenue.
Yeah, that is a staggering figure.
58% from just 5 entities.
That level of customer concentration means their financial stability is deeply, uncomfortably intertwined with the fortunes of a handful of specific EPCs or utility buyers.
That seems like an existential risk. I mean, if just one of those top 5 EPC contractors decides to switch their preferred vendor status over to a competitor like Voltamp or TNR, or even if one of those clients simply experiences their own bureaucratic delays in land acquisition and pushes back all their transformer orders for a year.
Which happens all the time in infrastructure.
Right. Doesn't Shilchar's factory floor suddenly have gaping holes in its production schedule? And as we discussed, idle capacity destroys operating margins overnight.
It is undoubtedly their Achilles heel regarding revenue stability. The loss or delay of a single major client would create an immediate vacuum in their order book. And this extreme customer concentration ties directly into a third, purely operational risk.
Which is?
The delay in cash conversion.
I'm glad you brought that up because it is a glaring detail in the financial analysis. In FY25, their net income looked fantastic on the income statement, printing at $1,469 million. But their actual operating cash flow generated from the business was only $395.63 million.
A massive gap.
Yeah, and the research attributes this substantial gap directly to money tied up in receivables they are waiting to get paid.
And the logistics of EPC billing milestones can be absolutely brutal for equipment suppliers.
Right.
The gap between recognizing revenue and actually collecting the cash is the hidden stress test of this industry. When Shilchar completes a transformer and dispatches it from the factory, they recognize the revenue on their books. The profit looks excellent on paper.
But the check hasn't cleared.
The check hasn't even been written. The EPC contractor might not release the actual payment for 90, 120, or even 180 days.
Half a year.
Yes, the payment might be contingent on the transformer arriving at the site, clearing a secondary round of inspections, or even waiting until the entire substation is commissioned and live.
So it's essentially like doing a huge, expensive renovation for a client who promises to pay you next month.
Exactly.
You are technically profitable on paper, but your bank account is empty while you wait. You have to purchase the CRGO steel today, you have to buy the copper today, you have to pay your engineering staff and factory workers today, but the cash for the finished product doesn't hit your bank account until 2 quarters later.
And surviving that logistical delay without blowing up the company requires an iron grip on the balance sheet.
I can imagine.
It requires immense working capital discipline. If a company mismanages that cycle, they can easily go bankrupt while technically showing record profits on their income statement.
Because they just run out of cash.
Right. They run out of cash to buy the raw materials for the next order while waiting to get paid for the last one. And layering over all of these operational risks is the sheer cyclicality of the infrastructure sector itself.
Oh, right.
Any macro pause in government discom capex, any policy delay in renewable project rollouts, directly and immediately impacts the order book of these equipment suppliers. So, navigating these intense commodity swings, managing a highly concentrated customer list, and surviving the brutal receivables lag requires serious discipline at the executive level.
Which forces us to look at the people actually writing the checks and steering the strategy.
The management.
Yes.
Yeah.
Shilchar is a classic promoter-led organization. The Shah family holds a dominant 62.12% stake in the company, which is down slightly from 64.01% after a minor open market sale recently.
Still a very firm grip on the wheel.
Definitely. The managing director, Alay Jitendra Shah, personally holds 24.56%. And what I found really notable is that the research explicitly describes him as a technocrat with an engineering background. This isn't a financier running a spreadsheet from a remote office in a suit. It is an engineer actively managing a heavy industrial plant.
And the technocrat leadership model is often highly effective in niche manufacturing because the executive actually understands the physical constraints of the factory floor, not just the financial model.
They know how the sausage is made.
Exactly. And their financial structure reflects a very specific, highly conservative mindset.
Yeah, this part blew my mind.
Their gross debt is zero.
Zero.
Their net debt is negative. They concluded FY26 with cash and equivalents sitting at 246 crore.
That's a lot of cash to just have sitting around.
It is. This enormous 14,000 MVA capacity expansion we analyzed earlier, it is being funded entirely through internal accruals. They are not borrowing a single rupee from the banks to double the size of the company.
Running a heavy industrial manufacturing company, an industry defined by massive capital requirements and volatile supply chains with absolutely zero debt and 246 crore sitting in the bank is incredibly unusual.
It's almost unheard of.
Most infrastructure companies use aggressive leverage to maximize their returns during boom cycles, right? They borrow as much as they can.
Usually, yes.
But by operating debt-free, Shilchar has essentially built a fortress against those exact macroeconomic and cyclical risks we just discussed. They are effectively bulletproof against central bank interest rate hikes, which is a rare advantage when borrowing costs usually dictate the viability of most infrastructure projects.
It is the defining characteristic of an owner-operator dynamic.
What do you mean?
Because the Shah family owns over 62% of the equity, they manage the company's balance sheet with the same risk aversion one might apply to their personal savings.
Oh, like treating the company checkbook like their personal checkbook.
Exactly. That deep conservatism explains the pristine, zero-debt balance sheet. However, it also explains the dynamics of their related party transactions, which definitely requires scrutiny.
Yeah, let's talk about that.
The direct remuneration is substantial. Mr. Ali Shah took 829.61 lakh in remuneration, and Mr. Ashay Shah took 152.11 lakh. On the positive side, there are no pledged promoter shares, meaning they haven't used their equity as collateral for outside loans, but the broader public disclosure is notably limited. We do not get a granular breakdown of their order book, nor do they publish specific segment economics for the different transformer classes.
Okay, I cannot let that remuneration figure slide without pushing back a bit.
I figured you wouldn't.
Over 8.29 crore for Alay Shah alone. That is an exceptionally high payout for a company generating roughly 650 crore in top-line revenue, especially in a year where the net profit remained completely flat at 158 crore.
It's a large figure.
If I am a minority shareholder looking at the FY26 results, how do I know this isn't just a dominant family treating a publicly traded entity like their private domain? Is this just the accepted premium you pay for a founder who successfully built the moat, or is this a genuine governance red flag? Taking over 5% of the total net profit as a single executive salary seems difficult to justify when earnings growth has stalled.
It is a significant governance debate, and institutional investors scrutinize these exact ratios all the time. In pure isolation, drawing over 8 crore in salary on 158 crore of flat profit is elevated, and it absolutely warrants continuous monitoring by minority shareholders.
Right.
However, the market often contextualizes that remuneration against the broader operational execution.
How so?
While the profit was flat, the company maintained near 30% EBITDA margins in a historically low-margin sector. They navigated a brutal supply chain shock in Q4 without dipping into the red, and they are entirely self-funding a doubling of manufacturing capacity without taking on a single rupee of debt or diluting shareholders.
So they're delivering results.
They are. If this company was heavily leveraged, struggling with interest payments and missing delivery targets, that 829 crore salary would be a glaring, unacceptable red flag.
People would be up in arms.
Exactly.
Yeah.
But in the current context, the market appears to view it as the steep price of retaining a technocrat who has undeniably steered the ship into a highly profitable, debt-free position. But you're right, the tension between family control and minority shareholder returns is always present in these structures.
Yeah. Okay, so synthesizing this entire analysis, we started by looking past the abstract policies of the energy transition to examine the raw physical hardware of the grid.
The literal nuts and
Yes.
bolts.
We unpacked how Shilchar designs and tests bespoke distribution and subtransmission transformers, acting essentially as a biological matchmaker for grid infrastructure. We analyzed the structural 25-year replacement cycle currently unfolding across India, driven by aging assets and intense thermal degradation from climate stress.
The baking effect.
Right. We mapped out their highly specific niche strategy, avoiding the brutal PSU price wars to focus on complex EPC relationships and high-margin exports to the Middle East.
Which is where the real money is.
Exactly. We marveled at a completely zero-debt balance sheet funded by internal cash, and we stared down the looming existential threats of raw commodity spikes, extreme customer concentration, and the brutal logistical drag of EPC payment cycles.
And that comprehensive view leaves us with the ultimate market debate surrounding Shilchar. Is this company durably exceptional? Had their custom engineering capabilities, strict export qualifications, and preferred vendor statuses built a genuine, defensible moat that will protect those premium 30% margins?
Or
Or are we simply analyzing a well-run, conservative company currently sitting at the absolute peak of a cyclical infrastructure wave, a wave that will inevitably mean revert as global copper prices remain elevated and larger competitors aggressively target their niche?
it is the defining question for anyone tracking the industrial sector right now, and I want to leave you with a final thought to ponder, something that builds on the physical realities we've discussed today. Think about the global narrative. As the entire world sprints aggressively toward AI data centers, electric vehicles, and hyper-electrification, we constantly assume the ultimate bottleneck will be software capabilities, right? Or the mining of lithium for batteries, or perhaps even the sheer scale of power generation itself.
That's what makes the headline.
So what if it isn't? What if the ultimate unavoidable bottleneck to the future is the heavy physical transformers required to step that power up and down?
The physical hardware.
Exactly. If a highly specialized, efficient, completely debt-free company in Gujarat is already struggling to absorb the surging logistical costs of transformer oil and copper today, what exactly happens to the stability of the global grid when the real systemic supply crunch hits? Thank you for joining us on this deep dive. Keep questioning the invisible infrastructure around you.